This is a showcase of my project for MAT301, where I created a neural network for digit recognition. The way this program is structured is there's an input layer with 784 neurons, one for each pixel of the input images, which are 28 by 28 images. And then the hidden layers have 10 neurons each, and then the output layer has 10 neurons, one for each digit that the neural network can predict. Within this neural network, there's different values that can be changed. One of them is the amount of hidden layers that the neural network can have. You can choose either 2 or 3. Another is the learning rate, and another is the number of epochs you can run the program with, for. I also included some debug messages that you can choose whether you want to display or not, just to help understand what's going on. So just to showcase this real quick, let's say we are going to first turn on the debug messages, and then we're going to create a neural network with 2 hidden layers, learning rate of, let's say, 0.3, and then we're going to run it for 1 epoch just to see the functionality. Okay, let me scroll all the way back up. So this is just to show the training data and the testing data. The training data for the neural network is a set of 60,000 images. Here I'm displaying the labels for some of them, and then the testing data is a set of 10,000 images. The way this program is structured is I set it up so that it first trains the network and then straight after tests the network with the testing data. The way that this is done is, well, it first initializes some parameters for training the neural network. It initializes a bunch of random values from minus 0.5 to 0.5 for the weights and biases of the different layers. So here you can see all the values that they have. There's a set of weights 3 and biases 3. They aren't used throughout this specific scenario. That's mostly for when the network has 3 hidden layers, but I still displayed it anyway just to show the functionality. Why that's displayed is explained later on in the code. So then it does forepropagation, where it will show the results of all the formulas, and then it'll start backpropagation to start training the network. So it runs through, does all the derivatives. These are all the different values that show up. As I said, Z3, W3, B3, like the weights and biases for 3, which is the hidden layer 2 to hidden layer 3, aren't used in this case since it's a 2 hidden layer neural network. And then all the weights and biases get updated. These are the different matrices for that. And then once that is done and the network is trained, well, after all the epochs are run, but this is only one in this scenario, obviously, then the neural network is tested. So we only do forepropagation since we want to see what predictions the neural network gives automatically. We don't do backpropagation or updating the values since that would train the network and we don't want that. So we start forepropagation with the testing images, and these are the results that we would get. And we see that the accuracy is 0.13. This is quite low since we only run it for 1 epoch. And yeah, that's the way that the neural network works. So let's say we ran this again and did it for, let's say, I'm gonna turn off the debug messages this time. Let's say we did 3 layers with a learning rate of 0.3 once again, but we ran it for 100 epochs. Oh, there will also be a debug message when training the network that will show up every 100 epochs, but it did not display earlier because we only ran it for 1 epoch. That's mainly because obviously with neural networks you're meant to run it for a lot of epochs to make sure that it's getting trained and the actual accuracy can go up. So this is only with 100 times. The accuracy is 0.14. That's when training, and when testing we can see that's 0.15, so it's about the same.